I will be going over important points for section 6.1 with this video. Section 6.1 is called the inverse sine, cosine, and tangent functions. So we have a lot of objectives to cover in this lesson, but we're going to mainly focus on the inverse sine function, inverse cosine function, and inverse tangent function and their properties. Our first focus will be inverse sine function, and we're going to understand what inverse means, and we will remember their graph. So if we go back to our fundamental math 1316 topics, which is the sine function, it's the most famous function in trig class. This is what the sine graph looks like. It is an infinite graph, as you can see, because the domain for sine function is all real numbers. So the x values, you can take the sine of any angle you like. Therefore, domain for the sine function is from negative infinity to positive infinity. But for sine function, the range is restricted. So when you look at the range of the function, as you can remember, range means the set of the y values on the function. The range is the minimum y value on the graph is -1. The maximum y value on the graph you can see is +1. Therefore, for the sine function, the range is restricted between -1 and +1. And it's always great idea to know the 5 key fundamental points on the sine function, such as sine pi/2 is equal to 1. So on the graph, sine 90 degrees or sine of pi/2 will go to the 1. Sine 0 is 0. And then sine of pi, which is sine of 180 degree, is a 0 as well. Sine is an odd function, so sine of -pi/2 will be just a -1. And then sine of -pi is just a 0. So knowing these 5 key points on the sine graph is going to really help you with your rest of your pre-cal and trig class. And then this is what the sine graph looks like. And then important points for the sine function, the domain is from negative infinity to positive infinity, and range is from -1 to +1. Now what's happening is, if you look at this graph, this blue spatial segment of this graph has been copied here because this just shows the portion only for these spatial values. So if we only take this portion of the graph, which runs from -pi/2 to the +pi/2, and it shows our 5 key points. And then if we are restricting the domain to -pi/2 to the +pi/2, the range is still the same. The sine graph is not going to go any lower than -1, and it's not going to go any higher than +1. So we are restricting the domain, and then we're still getting the same range. Why are we doing this? Because in order to define inverse sine function, we will have a restricted domain. And this is what the inverse sine function means. So sine to the power of -1 represents the inverse sine function. So when we read the definition, y equals sine to the power of -1 of x, if and only if x is equal to sine of y, where x is between -1 to +1, and y is between -pi/2 to the +pi/2. Now, for any function in math class, the function and its inverse, they switch their x and y value. So when we had y equals sine of x, if we want to now call it y equals inverse sine of x, the domain for the sine function, and this is what the restricted domain for the sine function was. Restricted domain for the sine function is -pi/2 to the pi/2. Now this becomes the range. And then the range here, which is the set of the y values, they become the domain for the inverse sine function. So inverse sine function is going to go from -1 to +1, and the range is from -pi/2 to the pi/2. Okay, we're going to have some examples to understand. So when we go over the example about sine of x and inverse sine of x, you can come back to this part of video and listen to this explanation again. So now, in math, the function and its inverse, they will be always symmetric to each other by y equals x line. So when I look at this graph, I see that the pink one belongs to the main function, which is y equals sine of x. But then if you just switch x and y values for every single point, so look at this, on the main function sine graph, when x is pi over 2, when the angle is pi over 2, corresponding y value is 1. So if you just exchange these two numbers, when x is 1, y becomes pi over 2. This is the point on the inverse of that function. And inverse of that function is expressed as sine to the power of -1 of x. So every point on this pink graph, if you exchange the x and y value, you're going to obtain the y graph, which will be the sine to the -1 over x, or we call it arc sine of x. And then this is very important for the inverse sine function, or you can just call it arc sine function. This will be the domain you all have to know, and this will be the range. So this is the domain for inverse sine, and this is the range for inverse sine. Okay, so we're gonna now look at an example to find the inverse sine of a value. So here's the question. Question is, can you find the exact value of inverse sine of -1? So if I translate this question to English, it tells me who is the angle whose sine value is equal to a -1, and you have to tell me an angle between -pi/2 to the +pi/2, because arc sine is only defined from -pi/2 to the +pi/2. As you know from the 13-16 class, sine functions, the same sine value might belong to multiple angles. It can belong to a lot of different angles, but then we're going to only be focusing on the angle who is in between -pi/2 to the +pi/2. Now, if you remember this, who is the angle whose sine value is equal to -1? Now, I know that sine of 90 degrees is 1, and sine of -90 is -1, right? Because sine is an odd function, so if you put a negative before the angle, it will affect your y value. So therefore, here, the expected answer will be equal to a -pi/2. So it is also very helpful that you do know this chart by heart. And these are the important sine values for some very famous angles. Sine of 0 is 0. Sine of pi/6, which represents the 30 degrees, is equal to a half. And then it ends in, so this is 45 degrees, this is 60 degrees, and this ends in 90 degrees 1. And then this is the right branch of the chart. And then when you change these angles to the negative versions, you're still copying the same outputs, but you're just putting a negative in front of each these y values, because for sine is an odd function, meaning that when you change angle from positive value to negative value, y values will change from positive values to negative values. So this is what the chart is going to look like. And then from this chart, what does -1 match with? -1 match with -pi/2. So that makes the answer to that question to be equal to a -pi/2. So for when you see these questions, let's go back to the question again. The original question was, can you find the exact value of arc sine of -1? Meaning that what is the angle whose sine value is equal to a -1, and you will always have to know that the angle must be between -pi/2 and +pi/2. And from the chart, we know that there's only one angle within this interval from -pi/2 to +pi/2. The only angle who has the sine value is equal to a -pi/2. So this is how you are going to answer these questions. We're going to look at one more example in this format. Can you find the exact value of sine to the power of -1 of square root of 3/2? So I want to again think this question in English. So what is the angle whose sine value is equal to square root of 3/2? And never forget that angle must be between -pi/2 and +pi/2, because arc sine is only defined within that interval. So square root of 3/2, if you go back to the same chart that I showed you a minute ago, square root of 3 over 2. I have the positive square root of 3 over 2 here, and I have the negative one here. But in this question, I have the positive one. So it's matching with what angle? Pi over 3. So in this question, the answer will be pi over 3 because sine of pi over 3 is root 3 over 2. Therefore, inverse sine of root 3 over 2 is pi over 3. So I hope you're understanding how the function and its inverse, they switch their x and y value. I have two more questions here, but if you look at these two more questions, these sine values, they don't belong to those famous angles we have to know by heart. So for this example, we have to use a calculator. Question is, can you find an approximate value of each of the following functions? Inverse sine of 1 over 3 and inverse sine of negative 1 over 4. Express the answer in radians rounded to the 2 decimal places. So you have to make sure that your calculator is in radians mode. So let's just go ahead and do this one on decimals together. So I'm going to share this slide, and I'm going to actually share my, just the screen. And then I will find the inverse sine of 1/3 using decimals. So I'm going to go here, and I will go to decimals.com. And then it'll open up the graphing calculator. So first thing I do is I go to this graph settings, and I have to make sure that I am on radians. So you can switch between degrees and radians like this, but if you pay attention to this question, they told me that I need to give them the answer in radians. So I am choosing radians. And the question I'm going to enter is sine to the power of -1, because this is what inverse sine means. And then the value we have in the current problem is 1/3. So this is the answer I get as a radian. I go back to the homework and read how many how many decimal places they want. 1 second. Let's here. Round your answer to 2 decimal places. So I'm going to go back here, round your answer to 2 decimal places. 2 decimal places. So this is going to be 0.34 because 9 makes me go 1 digit up. So it's going to be 0.34. So we go to the slides. First one, answer is going to be 0.34. And then as you can see here, the answer is 0.34. The other question on the slide is, they want us to find the inverse sine of -1/4. So I'm going to go to the calculator again. Here, I'm just going to change this to a negative, and 1/3 is going to change with 1/4. So the answer is -0.25. So when I check the slide, it tells me that the second one has this answer -0.25. So example 3 is just the calculator application because these are not the sine values that we memorized in Math 13-16 class. Okay, now we can talk about the inverse cosine function. If you understood the inverse sine, they have a very same approach with inverse cosine, but of course their main graph is different, so their domain and range is going to be different. So when we look at the cosine function here, this is what a typical cosine graph looks like. And again, if you know the 5 critical values for the cosine function, which is cosine of 0 is 1, cosine 90 is a 0, cosine of pi is -1, cosine of 3 pi over 2 is a 0, and cosine of 2 pi is 1. So as you know, trig functions are periodic. So this is the one period of cosine function. This curve, this V shape, is one full curve for the cosine function, full cycle. So for the cosine function, normally the domain is again from -infinity to +infinity, which means that you can find the cosine value of any angle from -infinity to +infinity, and its range is from -1 to +1. So the cosine graph is going to go as low as -1 and as high as +1, and this is the range for the cosine function. Now, what's happening here is they're only copying this blue section on a separate graph. And then here, this one is cosine of 0 is 1. That's where it starts from. And it ends in cosine of pi is -1. Because these are the unique y values of this graph here. Now, for the cosine of x, if you restrict your domain to 0 to pi, you're going to obtain all these unique y values, and your range is going to still stay at -1 to +1. Now, this is your cosine graph. For the inverse cosine, since you have to switch your y and x values, now your domain for the inverse cosine will be -1 to +1, and your range will be from 0 to pi. Again, the function and its inverse. All they do is they exchange their x and y values. The x on the first one, so the x on the first one becomes the y on the other one, on the inverse. So I'm going to explain this sentence one more time on the graph. So the red one is here, the original graph of cosine of x, and then the blue one is the inverse cosine function. So every point on the red graph, if they switch their x and y value, you will obtain the blue graph. Just like any other function and its inverse pair in math class, the function and its inverse, they're going to be symmetrical to each other by y equals x line. So look at this. The blue graph has 1, 0. So if you change the location of these two numbers, you will get 0, 1 on the red graph. Again, red graph is pi, -1. If you change the order of these two numbers, the blue one is going to have -1, pi. So we're going to now look at some examples with the inverse cosine function. So the first question is, find the exact value of inverse cosine of half. Again, if I think this question in English again, so basically they're asking me to give them the angle whose cosine value is equal to half, but for inverse cosine, I can only give them the answer from 0 to pi. The angle must be between 0 to pi because that's what the domain for inverse cosine is. I cannot give them any answer outside of this answer. So if you create a chart for cosine function, for what angle cosine value is equal to half, this is a very famous cosine value. And then if you remember the chart, cosine of 60 degree, because pi over 3 represents a 60 degree, cosine of pi over 3 is equal to half. So if I am looking for inverse cosine of half, the answer will be pi over 3. I want to remind you again, when you see these inverse cosine questions, they're asking you what is the angle whose cosine value is equal to half. So inverse cosine of half is pi over 3, and you will never forget that inverse cosine accepts answers from 0 to pi, where inverse sine accepts the answers from negative pi over 2 to the positive pi over 2. Okay, so I have another question in this format. They're asking me to find the exact value of inverse cosine of -√3 over 2. This is another famous cosine value that I need to remember from math 1316. Inverse cosine of -√3 over 2. Okay, remember that for inverse cosine, you can only give them an answer from 0 to pi, right? Only 0 to pi. So you go to your chart again. So for cosine of 5 pi over 6, the y value is -√3 over 2. So this is the main chart for cosine. Cosine 0 is 1. Cosine pi over 6 is √3 over 2. Cosine pi over 4 is √2 over 2. Cosine pi over 3 is a half. Cosine 90 is a 0. So you all have to memorize these charts for sine and cosine. Therefore, for this question, guys, when it is asking you to find the angle whose cosine value is equal to -√3 over 2, your answer will be 5 pi over 6, because inverse cosine only accepts answer from 0 to pi. Okay, next one is, if you understand the sine and cosine, inverse tangent gets a little easier. It does have difference parts than the inverse sine and cosine, like asymptotes, but let's take a look. Now, this is what the tangent graph looks like from trig class. Again, this is what the tangent graph looks like. These purple ones are asymptotes because tangent function is not defined when the cosine value of the angle is equal to 0, because tangent is sine over cosine Whenever cosine is equal to 0 for any angle, cosine becomes undefined. So this is what the tangent function looks like in a lot of different periods, right? So for tangent function, the domain is still from negative infinity to positive infinity, but you have to exclude the angles who are the odd multiples of pi over 2, because tangent 90 doesn't exist. Tangent 3 pi over 2 does not exist. Tangent 5 pi over 2 does not exist. Therefore, whenever x is equal to odd multiples of pi over 2, so this is an even multiple because this is 2 pi over 2, this is 4 pi over 2. But whenever you have the odd multiples, like 1 times pi over 2, 3 times pi over 2, 5 pi times pi over 2, your tangent function is undefined. Therefore, your domain has some restrictions, but your range is this time from negative infinity to positive infinity for the tangent function. Again, if you only get the unique y values of one period of the tangent function. So one period of the tangent function runs from negative pi over 2 to the positive pi over 2. And then the range is equal to negative infinity to positive infinity. When you talk about inverse tangent function again, your x and y values will switch. So therefore, for inverse tangent, your domain is from negative infinity to positive infinity, but your range will be equal to negative pi over 2 to the positive pi over 2. So we're going to look at the tangent graph and the inverse tangent graph. So the pink one is again the tangent graph's shape from negative pi over 2 to positive pi over 2. If you just exchange all these points, x and y values, you're going to get the blue graph, which is the inverse tangent graph. And then what you have to know for inverse tangent function is x can be anything from negative infinity to positive infinity, and the y can be anything between negative pi over 2 to the positive pi over 2. So we're going to look at an example again with inverse tangent. For inverse tangent, the question is, what is the inverse tangent of negative root 3 over 2? What is the inverse tangent of negative root 3 over 3? Which means, who is the angle whose tangent value is equal to a negative root 3 over 3? That's what the question is. Now, so the angle whose tangent value is equal to negative root 3 over 3 is just negative pi over 6. So this will be the expected answer. And you just have to make sure that when you're providing an answer for inverse tangent function, the answer has to be between negative pi over 2 and positive pi over 2. This is the exact same interval for inverse sum. Okay, now we're going to look at some properties of inverse functions. Okay, so inverse sine of x is just basically x. And then if you take the inverse of the x, inverse sine of the x, and then take the sine, you still get the x. So what they are saying is here, if you calculate the sine of pi over 9, then you try to think about what is the inverse sine of that value. So who's the angle who has that sine value? You just basically get the angle you see in the middle. This composite function, inverse sine of pi over 9, follows the form of the composite function property because pi over 9 is this interval. So you're just going to get pi over 9. Same thing here when we think. It follows the same rule that they taught us. But if you look at the inverse sine of negative 2.5 here, it doesn't exist because you can take the sine of an angle. The sine of an angle is not lower than negative 1 and it's not higher than positive 1. So since here they gave us a number who is less than negative 1, this doesn't exist. So sine of something doesn't exist, also not defined. It's going to be the same rules for cosine. And then if you look at it here, when you have the cosine of pi over 15 here, you can find its numerical value. And when you think backwards, who is the angle whose cosine value is this fraction you got here? You will just end up with pi over 15. Now, for B, Now, the angle negative 3 pi over 4, it's not in this interval. So the property of cosine composite functions cannot be used. However, because the cosine function is even, cosine of negative 3 pi over 4 is the exact same thing as cosine of 3 pi over 4. Now, because 3 pi over 4 is in this interval 0 to pi, you can still apply this property because cosine of negative 3 pi over 4 is going to be the exact same value as cosine 3 pi over 4. And you can get a fraction for this. And when you think backward, who is the angle whose cosine value is this fraction, you're going to get 3 pi over 4. When we look at the property with tangent and inverse tangent, the same property applies. Now, next one we're going to look at is find the inverse function of f of x is equal to 2 times sine x minus 1, where x is negative pi over 2 to the positive pi over 2. And then we want to find the range of f and the domain and range of inverse f. Now let's see how we're going to find the inverse of this function. Again, finding inverse in math is just switching x and y. So first, we're going to change the f of x with y equals 2 sine x minus 1. And then where we see y, we're writing x. Where we see x, we're writing y. And then we're isolating the sine of y. Sine of y is equal to x plus 1 over 2. Now the y can be calculated because now y is the angle. Y is equal to inverse sine of this value. Therefore, this will be the inverse function for the question here. So to find the range for y equals 2 sine x minus 1 for sine of x, use the fact that sine of x's can take only values from -1 to +1. So y equals sine x minus 1, we already solved this for sine of x, and this is what we get. And because sine of x can only take values from -1 to +1, so whatever the equivalent for sine of x can only take values from -1 to +1. And then if you solve this inequality for y needs to be between -3 and +1. That's how we're going to find the answer to these questions. So the range of f is -3 to 1, or this is what you put as an interval notation. Finally, we can look at the equations involving inverse trig functions. And here's an example. We have 12 times inverse sine of x is equal to 3 pi. To solve an equation involving a single inverse trigonometric function, you're going to isolate the inverse trig function. So this is given. You divide each side by 12 and you get inverse sine of x is equal to pi over 4. And then x will be equal to sine of pi over 4, because if you just switch the x and y value, if this is the inverse sine of x is equal to pi over 4, sine of pi over 4 is going to be x. And then sine of pi over 4 is equal to 2 over 2. And this is how you solve these questions. This is the end of 6.1. Good luck with the homework.